So today we're going to be looking at quotients with radicals. So quotient means they're going to be dividing. So we're going to be talking about having radicals in the denominator. So something like this. That would be in the denominator. And we can have anything on top, like a number or a variable, whatever. We can also have it in the bottom. But the problem is you don't actually use this as an answer. We usually get rid of square roots in the denominator. So I'm going to show you how to do that. And that way you don't have any square roots in the denominator. So how do you remove square roots from a denominator is our question for today. So here's a question. We talked about this before. What does it mean to rationalize the denominator? We did this before with imaginary numbers, if you remember. We couldn't have i's in the bottom, so we had something like 5 over, 3i or something, and we had to get rid of the imaginary number. So what does it mean to rationalize the denominator? It means to rewrite the fraction so that its denominator is only a number. In our case before, we had imaginary numbers in the denominator, and eventually we got rid of that and had something like 5i over 3 or something like that, and we didn't have anything in the denominator but a number. So we're going to do the same thing here. We just can't have square roots in the denominator. So if you remember from before, it's kind of the same type of strategy. Whenever we did this before, we multiplied the top and bottom fraction by I. Down here, we're going to do the same thing, except for it's going to use whatever the square root is. So in order to get rid of a square root, right, you would need 2 of them to get rid of it. So let me give you an example. We're going to multiply this, 1 over square root of 2, times the square root of 2 on the top of a fraction, times the square root of 2 on the bottom. So you'll see what happens as we go through this. The property that we used before in the last lesson was we put these two together because they're both square roots, and we can put them into one big square root and say it's 2 times 2. The top is just 1 times the square root of 2, which is the square root of 2. Careful, that's your division sign here. All right. And then the bottom, what do you end up getting is we get the square root of 2 over the square root of 4. And guess what happens there? We know the square root of 4 is 2, so this is the square root of 2 over 2 is the answer. Now there's no square roots in the denominator, and that's your answer. So the strategy here is that you just want to take whatever you have in the square root and multiply by exactly that. So we'll take this in our next example, and we'll multiply both things, the top and bottom, by the square root of 5 over the square root of 5. And the same thing's going to happen every time. So we can go through it one more time, but then I kind of want to do the shortcut of it. So the top will be 3 times the square root of 5. Nothing we can do with that. The bottom we can put together would become the square root of 25, but guess what we're going to get out? The square root of 25 is the number 5, and then we have 3 on top times the square root of 5. Now you can't cross out 5 with square root of 5 because they're not the same thing. When you have something underneath the radical, you can't cross that stuff out, unless you had the same thing on the bottom with the radical, but we don't. And we don't want to. So this is the answer with no square roots in the denominator. Okay, and the last one we have here, we have negative 13. Oh, wait, let's back up. I'll just immediately put the times symbol here. So we'll multiply by what? Get rid of the square root of 7 by multiplying by the square root of 7. So the top becomes, we'll just put the negative on top there. We have negative 13 times the square root of 7 over, if you understand the shortcut what's happening here, what do we end up getting? You would get the square root of 49, which just reduces back down to 7. So what really ends up happening is when you put these two together with multiplication, the square roots just go away. You just get whatever's inside the root symbol, which is, in this case, 7. And that would be your final answer. So we have one more that's a little bit more difficult, only in the sense that we have a variable in there, So we have 12x, and we also have a number that has a perfect square in it. If you look at the previous examples, we had 2, 5, and 7. They can't be broken apart. But now we have the number 12, and we can break apart 12. If we look at the perfect square roots, you'd be looking on your table on the x squared column. You could find that 12 is the same thing as 4 times 3. And we're going to break this apart first and simplify it, and then we'll get to rationalizing it, which is what our final goal is. So we have 3 over, if we break this apart into the square root of 4 times 3x instead of 12x, and then you can break that apart into the square root of 4 times the square root of 3x, and we happen to know the square root of 4 is the number 2 times the square root of 3x. Now we have something we can work with, where we're going to multiply the top and bottom to get rid of the square root of 3x by multiplying by square root of 3x on top and bottom. So the top is 3 times the square root of 3x. The bottom, when we put these two together, remember what's going to happen. You would end up getting like 9x squared and then square rooting that. That would get you back to 3x. So we have 2 times 3x. And I don't know if you noticed, but since we have multiplication with everything outside the square root here, the 3's here can cancel out. And so the numerator would be square root of 3x over the bottom. All we have left is 2x. The x's do not cancel out. This one's stuck inside the radical sign. Okay, so there's some team huddle problems to try. A and B. Let's look at letter C here. Look at this one. 3 over square root of 36. You don't have to do anything with this because you know the square root of 36 is just the number 6. So don't be jumping the gun and trying to multiply, the top and bottom by square root of 36. You can just simplify this the way it is and get 3 over 6, which is the same thing as 1/2. That would be your final answer. Let's check this one out here too. You could try to break apart 6. Unfortunately, that's 2 times 3, and that doesn't help us. So this one you'd have to multiply by everything. The square root of, back up a second. If we don't talk about the numbers, you can take something out. This will be a little interesting. No, let's put equal sign there. You can take out, right? Remember there's a little 2 here. We can take out some n's, right? So let's just keep this 8n over here. How many times does 2 go into 5? Because we have an exponent of 5 here. We can take out an n squared. And then there'd still be 1 left on the inside, right? Because that gets you up to 4, so there's 1 left. And I can go a little further here. I can actually cross out 1n on top with 1 on the bottom, so there'd still be 1 left on the bottom. So this is actually 8 over n times the square root of 6n. Now we can multiply, since we can't simplify any further, square root of 6n over the square root of 6n. Remember, just keep the same thing. So we get 8 times the square root of 6n over n times, now what's going to happen here? They're the same thing, so we're just going to get one of those sets out, 6n. And we have the n's go together, so we'll get n squared. And then 8 over 6 is the same thing as divide these by 2. You can get 4 and 3. So we have 4 thirds times the square root of 6n. And this would be the furthest we could go. That one's pretty tough. We're going to do 2 more examples, I believe. Maybe do the challenge problem too. Let's see. So, all right, for the third example, we have 3 over 4 plus the square root of 7. We're going to put that in a plus b times the square root of c form, which you kind of familiarize yourself with this, where we used to have a plus bi form, if you remember. Now we're going to have the square root of c. Don't worry about that too much. You're going to see what we get in the end. So this is almost the same as when we talked about complex numbers when we did I. we do something called multiply by the conjugate. Does anybody remember what the conjugate is? I'm just going to copy the problem down. Remember, we multiplied this by the conjugate. The conjugate is whenever you take the denominator and you just change the sign on the inside to 4 minus the square root of 7. So we're going to multiply the top and bottom by 4 minus the square root of 7. And you'll see what happens. Put parentheses around everything, so we got to do some multiplication here. So we'll multiply this one out. The 3 goes to everything. 3 times 4 is 12. 3 times negative 7, negative square root of 7, that just sits like this. Negative 3 times the square root of 7. Can't do anything else with it. It doesn't go inside the radical for any reason. Bottom, we have to multiply this stuff out. 4 times 4, 16. We'd have 4 times negative root 7, so minus 4 root 7. Can make this a little longer. We would also have square root of 7 times 4, so that's a positive 4 root 7. And the last one would be square root of 7 times square root of 7, which we would get the square root of 49, which we've seen this before. If we put these two together, we're just going to get the number 7. Oh, wait, it'd be minus 7. Sorry. Right? A positive times a negative. So if you notice what happens here, these middle two terms here, one's positive, one's negative, positive 4, negative 4, same thing. These are going to cross out. Now we've had this happen to us before. So now we have 12 minus 3 square root of 7. The bottom is crossed out here, and we can combine 16 minus 7 to get the number 9. And we can go a little bit further. We can divide these both by 3. We'll divide everything by 3. Or if you want to, you could split it up this way. You could say it's 12 over 9 minus 3 root 7 over 9. Then we can divide everything by 3, besides the square root of 7, obviously. So it looks like our final answer will be 4, divide these by 3, over 3, minus, divide these by 3, 1 root 7 over 3. And that's our answer. That's technically in the a plus b square root of c form, and that's also its most simplified version. All right, let's try another one. We're going to start with write 2 over 3 minus square root of 5 in a plus b square root of c form. So 3 minus square root of 5. We're going to multiply this by the conjugate of the denominator, which is 3 plus square root of 5. 3 plus square root of 5. And it's probably easiest just to put parentheses around these when you're solving these. All right, so we'll distribute this. You get 2 times 3, which is 6. The 2 will just sit next to the square root of 5. Just times them together. The denominator, if you remember, these middle two terms are going to cancel out. So we need the first term, 3 times 3, which is 9. These other two are going to cancel out. If we do 3 times 5, or square root of 5, we get 3 square root of 5. Look what happens again here. Negative square root of 5 times 3 minus 3 square root of 5. You can write it the same way. So they're going to cancel out. And our last one, negative 5 times the square root of 5 would be minus the square root of 25, which is 5. Okay, the middle two terms will cancel. I'll cross those out again. Positive 3 root 5 minus 3 root 5. So we get the top stays the same. 6 plus 2 square root of 5. The denominator is 9 minus 5, which is 4. So I'm going to do the same thing here where we break it apart. This would end up being 6 over 4 plus 2 square root of 5 over 4. And then just divide everything by 2, because that's how they can simplify. So we would get 2, whoops, no, not 2. Divided by 2, you get 3 over 2 plus 1 square root of 5 also over 2. And that would be your answer. And that's pretty much it. I mean, you do a couple of the huddle problems. There's some more to try yourself. Number 1, you're just going to multiply this one by 1 minus square root of 3. This one will have 5 minus square root of 5. Some things will cancel out here. You could not cancel these two out because you have this plus between the two things, these two terms. So you cannot cross these out. No. Don't do that. There you go. And there's one with an R in there. That's not too bad. Maybe I might do that one. And then maybe go over the challenge one, and then we'll wrap this up. So for part C, I would multiply this by 6 plus the square root of R. 6 plus the square root of R. So we multiply these together, we get 24 plus 4 square root of R. The denominator, if you remember, we need the first 2, which is 36. Whoops, let's get rid of that. Okay, that was not much better. And then we know that these two middle terms are going to cancel out, so we don't need to write them out. The last one we have is a negative square root. What you actually get is R squared, which just takes it into R. So let's get rid of that. Minus R. I think we're pretty much done at this point because we cannot combine these two things, right? So 24 plus 4 square root of R all over 36 minus R. I don't even know why I rewrote it. I mean, that's the answer. You can divide everything here. Oh, no, yeah, that's the answer. You could divide everything here by 2 if you wanted to, or even 4. The problem is this cannot be divided by 2 or 4. So you really can't go any further with this problem. That's it. Okay, last one, which is the finale one, which is a challenge problem. I'll go over that one real quick. It says a friend tries to rationalize 1 over the cube root of x. So we haven't talked about cube roots yet. By performing the following multiplication. So this person took 1 over the cube root of x times cube root of x times cube root of x. Explain why this method will not work. Well, let's just try and see what happens. 1 times this doesn't change anything. We get 1 over the cube root. We get just cube root of x on top. The bottom, what happens when we put these two together? We would get the cube root of x times x is x squared. So what's the issue here? You have 3 trying to go into 2. Does not work. 3 does not go into 2. So we can't do anything. It equals not like question mark. What do? We didn't get rid of the cube root. Now, why does this not work? Because we don't really have enough to take out for the cube root. Devise a method to rationalize the denominator of 1 over cube root of x. So what do we need to get this out of here? We need an extra x. We want this to be x cubed. So what if instead we multiplied, instead of the cube root of x, what if we multiplied this by the cube root of x squared on top and bottom? So the top will be cube root of x squared. The bottom, if we put these two together, you get the cube root of x times x squared. Now we have x cubed. They're the same. Oh, I think we're doing part C. Rewrite 1 over cube root of x as a rational power of x. Guess we're answering this right now. So this becomes a cube root of x squared. And then this will cancel out and just give you x. And since we have no more radicals on the bottom, that's your answer. You can't cross out anything here because this x squared is not outside of the radical. It's stuck with the cube root. So now we actually did, we rewrote it as a rational power of x. So there's your challenge answer. All right, and that is the end of 8.6.